3 video series. This video is about building Tokenizer from scratch. This is a complete playlist of 3 videos, where the first video was about data pre-processing. We learned how to clean the data, and then we got our unique words to get our vocabulary. We have gotten our vocabulary from that, and then in the second video we understood how GPT-2 tokenizer and how the BERT tokenizers are working and what is the difference in there, and that knowledge we are going to use in this video to build our own tokenizer. For this video, we are going to use the torch library and regex library. Make sure that in the first video, the unique words which we have created and the text format, you upload this text unique words here. And let's start with it. So first is you call the libraries, which is very important, and then you read the file and append all the lines to the list. So the complete words here, we saw that it is into the words are in the lines, right? What we are doing here is I am opening that file as f, and I am asking read the lines, and I'm storing it into the list of unique words. This is an empty library, and I'm storing the complete words into that, and you can see here it looks like something like this, the complete words, and all the words are stored into the list. The next is to remove the next line character. This next line character, if you want to remove, this is a simple code where I'm just a dot strip I'm doing, and I'm removing those words, and you can see the first 10 words if that I have removed this next line character. Then we join all the words to look into into a semantic into one line, so that it can be done without this also, but just for being helpful, this looks better to me, and I'm doing this. Then we define our spatial tokens. So we saw in BERT 2 that they had the spatial token. There's a start token, there was a final token, and there was 2 tokens. There was mask token also, which we saw that how it is different, how the spatial token are submitted within the first 1000 tokens. So for this our model, our tokenizer, I'm going to use this 4 tokenizers, spatial tokens. That is, first is initial, which is going to be our start token. Then final token is I'm calling it as final, and then mysterious token, like some word which is not known, and if it doesn't understand what does it mean, it is going to use mysterious in place of that. If any token which comes up and it doesn't understand, it is going to use mysterious in place of that. And then is padded token, that whatever extra space is there, I'm going to pad it with the padded token. Then simple as we are going to define a function to tokenize the words. There's this function which we have defined. We are putting the text data into here, and then I'm defining the function on basis of the space and the periods, and I'm not using here any of these symbols and words, any symbols and numbers here, but in the production level, again, if this is very important, that when we are building the corpus for our vocabulary or the tokenizers for our own business or for own business purpose, we all have spatial words or characters which are important to us. Here I'm not using them, I've removed everything. I'm just on basis of space and periods, I'm taking those words and making them as my tokenizers, as I told you in the first video. But in your production level, where we are doing if we want and our numbers and our words, some special characters to be kept into the tokenizer, because it is important for that business context to understand, we have to keep that, and then we have to divide the tokens on basis of that. But for here, I'm just taking every word as my tokens and dividing on basis of space and periods. So I define this function here, and then let's see how does it look. So this is I'm saying that I'm building a tokenizer, and I'm asking it to create token, and what it does is it builds the tokenizer, that it's taking every word on basis of space and period. It is taking the word and making the into tokenizer. So the here tokenizer is I is one tokenizer, M is one tokenizer, building is one tokenizer, and all this is a one tokenizer which I'm using. Then what I'm doing here is convert our unique words into tokens. So all those unique words which we have created here, these unique words which we have joined, these unique words I'm creating into my tokens, and then I'm putting into this all these words in set, that because I don't want any duplicates, I want only individual values, and then we are sorting it into ascending form, so that when we are going to index it, that is that indexing is kept, that is meaningful. Later on next step we are going to index it, so that is very important that you sort it. So when you do this and you run this, you can see all these words are sorted, and this comes into the unique tokens are converted into the These are our unique tokens. So all those words, unique words, are converted into unique tokens. So what I'm doing here is that these spatial tokens which we have kept, I'm adding these spatial tokens into my this complete token library. This is the complete token library. I'm appending all these tokens, these 4 tokens. I'm appending it into my library. So here what I'm doing is I'm calling it reorder tokens empty list, and I'm just saying if these unique tokens are not present in this list, I'm appending these tokens, or other tokens are appended, and then I'm appending these final tokens into the this reorder tokens list. Here I call the first 10 tokens and the last 10 tokens. So after the complete tokens, the first 10 tokens looks like this, and the last 10 tokens look like this. So you can see here all our 4 spatial tokens have been appended into these our unique tokens. So we have got our first we created our vocabulary, and then from that we created our tokens, and from these tokens we have appended our spatial tokens. Then what we are doing here, we are defining a function to assign index to each token. So what we need to do here is all these tokens which we have created, we need to assign index to them, right? We need to see what numbers they are here. So this is a function I have called empty dictionary, and I am saying for ID and token into the reorder tokens, assign every token, assign an ID. I am assigning into this. So if you see here, instead of this, I just show you a word to ID dictionary. What does it looks like? Is this. So every word has been assigned with one number. So this is what we are doing here. We are assigning index to the every word. So let's see if I'm calling the word above. What is the number of the word above? 53. It is present on the 53 number. It is the index of this word is 53. Next, what we are doing here, we have to define a function that if I know this token index, that I know this is 53 number word is above. I want to see which word it is. Here I know, but what if I don't know, and then I want to see which word it is, and then what I do here is I'm calling ID to word dictionary, and then for token comma ID and comma items, I'm saying that I'm getting the token for this, that which word it is actually is there. I'm just simply using this for loop, and if we run this function here, I'm saying okay, I'm giving you this 53 ID number, get me the token. So this token is above, and I've got this token. So we can see here that this is matching, and these are 2 functions which we have created to know this. Now what we are doing here is that I'm defining these token IDs for spatial tokens. So I'm saying that my initial token, what was my initial token here? My initial token was here, what I have assigned here is initial. So this initial token which was initial, I am assigning it to initial token ID. I'm adding this into my dictionary, that I want to assign initial token and define token IDs to spatial tokens. This is our spatial tokens, right? So we are assigning initial token ID to these our spatial tokens. You run this cell, these are 4 spatial tokens we have assigned it here. Then you see that initial token, the start token is our initial token, and that is ID number is 17091, and the end token is this one, and it is assigned with the number 17092. See, all those final words has been assigned with the number here. Okay, now comes the interesting thing, is we are going to build our encoder function first, that we are going to give it the text, and that text is going to get converted into the words, into the numbers. The text will be converted into words, and this word will be converted into the numbers. So what we are doing here is having 3 parameters: text, maximum length, truncate, and the return tensor. So what the text is doing is here is I'm encoding this text. This text is getting completely encoded, and then I'm using this maximum length, that the maximum length of the token sequence after encoding. What is the maximum length of this token sequence after the encoding, which is there? Because if it is not there, if it is extra, then we have to clip it, and if it is lesser, then we have to pad it. There is truncation. Truncation is the next, that if it is whether to truncate the sequence of maximum length. If you define a maximum length, that I want my tokenizer to just have this much of maximum length, and you don't want more than that, you are going to truncate it. So you define these 3 parameters here. These are 3 parameters which we are using, and then I'm calling my create tokens function, and I'm putting my text into that, which will be feeding, and I'm creating tokens from it. And from this token, what I'm doing here is encoding tokens using a for loop. All these tokens are appended into the encoded tokens. For token in tokens, token ID is equal to word to ID dot get token dot this function here, and I'm appending this token ID into the encoded tokens, whatever the tokens we have encoded here. Then from in this encoded tokens, what I'm doing here is I am saying I'm adding the initial token and the final token after every token, because after every word I want the start and stop, so to define that this is my token. So I'm adding this initial token and final token into that. Then I'm saying here if truncated maximum length is not none. Here I have defined it as none and false, right? But I'm saying if they are not none, then you truncate it and then you add this final token to that. This is a simple function to understand. And then I'm saying if return tensor is true, then you will return into the form of tensors. You convert these encoded tokens into tensors. Okay. So let's see this. So this statement, what I have gotten it from the text format which we have, this PDF file. I got the statement, and I'm asking it to distinguish between qualitative and quantitative data. So what I'm doing here is I'm asking it to convert into the encoded tokens. I have put this into text format, and I am calling this encoder here, and I put this text inside this, and I got my tokens. So this complete statement has been converted into the encoded tokens here. And if you see here, what is 17091 and 17092, 17091 is my initial token and 17092 is my final token. Okay, so now we are going to define decoder function. So what is decoder function here? What I'm saying here is that if my decoder index which I'm taking, if they are tensor, we have to convert those tensors into the list format. They should not be into tensors, because the functions we have, list dictionary we have developed above, that was not tensor, it was array, right? So we are defining a set of special token IDs which we want to skip. So once we give the index to this, we got this index, and then what we are doing, I'm asking here is that I'm having this special token IDs and putting into a set format, and if these are the special token, if the special token IDs, we are updating these special tokens into this set. Okay, then I'm doing here is I'm filtering out all the special tokens. I'm saying for ID in index, so for every ID in index, we have all the index of the encoders, and I'm saying for ID in index, if ID is not there in special token IDs, you add this, you get the ID to word. I'm storing into this word. This ID to word is dictionary which we have defined above. If you remember, we have defined this above here, ID to word, that from the word items we have defined that ID to word dictionary here, that all these words has been appended into this ID to word dictionary which we are using here. So what I'm doing here is I'm saying here if that for that index, getting the ID of that index, and that ID, and for that ID I'm getting the word from the ID to word dictionary, and then this word I'm storing in, I'm appending this word into the words, this words list, and then this in return I'm saying join all the words here. So I run this function here, and then what I'm saying, this encoded tokens which we got from the above, these were our encoded tokens, and I'm running this encoded tokens here, and I'm getting the decoded text. Okay, I hope this is understandable. So that's it, right guys? We have built our encoder function. We converted our words, we cleaned it, and then we can put it into the encoder, and we got the encoder words, and then we built our decoder function, and then we put it into the decoder function and built this decoder word. Then we can combine everything, all of these things, and make a class. Finally make a class for this, that is we add up everything and define it a class. So I defined a tokenizer function, I instantiated it, self.comma-text. All this methods which we have done here, I have added into a step by step. Again, they just added it into this function. All this function we have added into a class, all the complete steps. So initiated the initial tokens, final tokens, the special tokens. Then I tokenized the input text. I called my function create token function, and then I got the tokens from this. Then I got my unique tokens here. Then I sorted the unique tokens, and those sorted unique tokens, I added my spatial tokens here which I created, initial, final, mysterious, and parrot token. Then I assign index to each token. Every token has been assigned with one index. I'm sorry if the light is a little bit low. Yeah, and then for assign token to each index, I've defined a function that once we have got the index, you are getting the word from ID to word. For here we are getting the making the word to ID, and there here we are getting ID back to the word, and then we are defining token IDs for spatial token here, because we have created 4 tokens. We are defining the IDs for them. Then these are the functions which we have used again to create tokens. This is our encoder and this is our decoder. So this is a class which we define, the same function above which we have used. The same function has been used, and it has been this changed for the class. The self parameter has been added to describe it into the class. And then at last we got the encoder also, and we got the decoder also. This is the class which we created, and the name of the class is my tokenizer. So what we are doing here again is I'm calling my unique words. We are feeding here unique words, and I am tokenizing it. I'm getting the tokenizers for that, and I got the tokenizers from the vocabulary which we have created, the unique words vocabulary which we have created. I got my tokenizers from that, and then I'm encoding this word, this statement. I'm calling the tokenizer dot encoder, which we have created, function defined tokenizer dot encoder, and we got the encoded text. And then from we encoded text, we got the decoded text, and I'm printing it here. So my encoded text is this word has been converted in encoded text, and from the decoded text it has been converted into the decoded text. So that's how you create your own tokenizer. You build your own tokenizer from scratch. We started from the corpus of our own data, and then we cleaned it. We got our unique words. We defined what words we are going to use as tokenizers. Then we understood how GPT and BERT is working, and then we defined the functions to build our own tokenizer class and how it can be used. So remember that in production level, it doesn't necessarily need to be in words. It can be into subwords also, as done in the LLM models, or for our own production and corpus which we are using. Just to keep into mind that. And that's the end of this 3 video series, guys. I'm going to